Alright, hey everybody, let's actually get into Chapter 8. So yeah, we're leaving Chapter 5 behind us for now. Might take a little quiz later, but jumping into Chapter 8. And at most, we're only going to do a few sections in Chapter 8, kind of like we did with Chapter 5. So a few sections of Chapter 5, a few sections of Chapter 8 at the most ahead of us. And Chapter 8, starting off with 8-4, the chapter is called Rational Functions. Sounds fancy, but then again, you probably recognize that word rational when it comes to math. And what you should think of when you hear the word rational, especially, for this chapter, is you should sort of correlate the word fraction with the word rational. So we're going to be talking about a lot of stuff involving fractions. So if you have a pretty good background on simplifying fractions, multiplying fractions, dividing fractions, we might even get into like adding and subtracting fractions, you're in pretty good shape if you can remember just the basics of working with fractions. And spoiler alert, if you've got a pretty good grip on all the factoring we've done, this chapter, at least the next couple of sections, are going to go very well for you. So here we go. Simplifying a rational expression, just a fraction. A rational expression is in simplest form when its numerator and denominator are polynomials that have no common factors. So I'm not one to put too much weight on like a wordy definition like this, but I do want to reiterate, the whole like factoring thing. Remember, when you cancel things in a fraction, when something in the numerator and something in the denominator cancel out, those have to be factors. It's factors that are canceling to make a fraction more in simpler form or in simplest form, okay? But anyway, let's see this in action. So a little bit more good news to throw at you. The part of all these directions, whenever you see, state any restrictions, I'm not going to hold you to that. So I'll reveal the boxes and the answers for anyone that wants to give it some thought, but I'm not going to expect you on homeworks and or a quiz or something to have to do this part of the conversation. So let's just simplify. That I will hold you to. And you've seen this before. Like this was like remember like Unit X? Remember like it was literally while like when the shutdown happened, we were right in the middle of this like Unit X and all this review. We were doing this. Like this is not even new. So negative 27 divided by 9, like that simplifies. And then x to the third over x to the fourth. Remember, you could like subtract powers. Y to the fifth over y. You get negative 3, x to the negative 1 power, y to the fourth power. That was by subtracting powers. But remember, a negative power can't really stay a negative power for like a final answer. So you remember, anything that has a negative power would drop down to the denominator so that you could make that power positive. Okay? So again, this is not new at all, even for our class with me. And all this restriction stuff, I'll let you starting over here, I'll let you look at that on your own, but I'm not going to hold you to that. So pause the video if you want to, come back and look at it later, whatever. But all right, now we are taking it up a notch. So don't get too antsy and start working ahead of me, okay? Because remember, you can only cancel factors. If I made you again look at this and I told you to factor this, you'd look at me funny. You wouldn't know what I was talking about. Because you don't factor something like this. You already see the factors when the fraction is like this. You know, negative 27 is already like a factor. X, you know, factors of x and factors of y. You already see the factors. But in a problem like this, a fraction like this, where there's like multiple terms in the numerator and denominator, you should write this down. You cannot do any canceling or simplifying until you've factored. You have got to factor first. That is huge. You've got to pay attention to that little teaching point, okay? You must factor first. So again, I hope you haven't forgotten about GCF and unfoil and stuff. So how would you factor the numerator? Because again, you can't really cancel any factors out until you can see the factors. So how would the numerator factor down? Is there a GCF? No, but it sure as heck unfoils, because there's two numbers that multiply to make positive 25, but the same two numbers add up to positive 10, so it unfoils. How about the denominator? How does that factor? Does it even factor? You know, is there a GCF? No. Does it unfoil? Well, if it does, you wouldn't need Phoenix method. You know, are there two numbers that multiply to make 20, but they also add up to 9? Yeah, there is. And now you would cancel. Okay? Because now you see the factors, and look, this factor of x plus 5 will divide out, it will cancel with that factor. So any common factors, top and bottom, will cancel out. And whatever remains is your simplified fraction. So again, this isn't going to be that crazy, okay? Like, to simplify a fraction like this, you got to factor first and then cancel out the common factors. So it's like working with fractions and factoring. All that time we spent on factoring, hopefully you can kind of use that now again, bring it out of your toolbox. Now this is just like stating the restrictions on the variables, which I'm not going to worry about. If you want to worry about it, be my guest. But wow, that's it, huh? So yeah, remember, the factoring could involve Phoenix method, it could be special case unfoil, it could be GCF, but however you got to factor, you know, like sometimes you bring out a GCF from the top and a GCF from the bottom, and the two GCFs kind of simplify with each other, like, you know. So just make sure that you're factoring first. Now we're going to take a little bit of a leap forward. You know, what if we were going to multiply a couple of crazy fractions together? Multiplying fractions together, but at the same time, we're going to be simplifying. Like, you always want your final answer to be simplified, right? So, you know, maybe you remember how to multiply fractions. You know, what's the rule, people? How do you multiply two fractions together? Well, I really hope you at least kind of remember that when you multiply fractions together, you do numerator times numerator and also denominator times denominator. Let's see here. I don't know if this is how you were taught this, the exact verbiage, but you multiply across, right? Now, look at this. If I told you to multiply this trinomial to this binomial and this binomial to this trinomial, that's ugly town, right? It's doable, but no, you don't. That's not what we're doing. Here's what you're going to do. You want to do your canceling even before you multiply the fractions together, even before you slide the fractions together. So guess what? We're going to factor first. Okay, let's factor. Let's start up here can you factor 2x squared plus 7x plus 3? I mean, there's no GCF. So, if this unfoils, it's going to be by Phoenix method. All right, so, I hope you remember all the steps. You can go off to the side and do your Phoenix method. Like multiply the 2 to the 3 and then unfoil and then bring the Phoenix back to life and blah, blah, blah. Let me know if you need a reminder, a little refresher about how to do the Phoenix method. But at the end of the day, this is the factored form of 2x squared plus 7x plus 3. Now, x minus 4, that doesn't factor. X squared minus 16. Does that factor? Is there a GCF? No. Does this unfoil? Well, I mean, it's a binomial, so the only chance it has of unfoiling is if it's the difference of two perfect squares, which it is. And that would be the result of unfoiling this special case, x plus 4, x minus 4. And then this denominator, since there's no GCF, would this unfoil? Are there two numbers that multiply to get 15, positive 15 that is? But they also add up to positive 8. Oh yeah, there is. Okay, so now let's do some canceling so that, when we actually multiply these fractions together, there's less to worry about. So check it out. I hope you understand that you can cancel anything that's in the top with anything that's in the bottom. Like, you can essentially cancel diagonally. You can cancel diagonally here, okay, from fraction to fraction. So the x plus 3 bubbles are going to divide each other out and cancel out. Essentially they cancel out to like 1 over 1, technically. And you know what else? This bubble of x minus 4 will cancel with that entire denominator of x minus 4. Okay? So nothing else cancels. So now you're left with multiplying the 2x plus 1 to the x plus 4. And down here you just have maybe 1 over here and a 1. But really all you have is that x plus 5. Now, even more good news. I'm not even going to make you FOIL that together. You can just leave it as bubble, bubble. This bubble times this bubble. You don't even have to actually multiply them together. You can leave your answer like that. Does that sound good? Yep, I know it does. So yeah, more factoring, baby. And once again, this part of the story, stating restrictions on your variable or variables, I'm not even going to make you do, but you can ponder that if you want to later on. One more problem, that's it. So I'm also going to show you how dividing by a fraction works, even though you learned this years ago, how you divide by a fraction. So you tell me, smarty pants. Hey, don't call me smarty pants. How do you divide by a fraction? Well, to divide by a fraction, you would instead multiply by its reciprocal, or refliprical, as I say. Maybe you learned in the middle school that whole like keep, flip, multiply, or something. I'm probably getting that wrong. Sorry, middle school teachers. But keep, flip, opposite or something? I don't know. Keep, flip, multiply? I don't know. But yeah, that's how you divide by a fraction. So instead of dividing by this fraction, we multiply by the flip of it. So do you see how I flipped this fraction and now it's multiplying? So you keep, change, I don't know, whatever. Okay, now this problem is extra nice because it's already factored. Like I can already see the factors. So you're kind of, in this example anyway, you didn't even have to like do any factoring. You know what I mean? So you can go ahead and start saying, okay, so that factor of x minus 2 cancels out with that factor of x minus 2. And it looks like there's no other factors that cancel out. 1, 1. Or is there? I mean, obviously, 3x plus 2 doesn't cancel with like the 4 minus x or the 7x minus 5. The 7x minus 5 doesn't cancel with anything. But check it out, people. Plot twist. 4 minus x and x minus 4. Now, they're not the same thing. They're not. I'm not going to try to pretend that they are. 4 minus x and x plus 4 are not exactly the same thing. Now, on a side note, if this was a 4 plus x, with this being an x plus 4, that would actually be exactly the same thing. And if these were both pluses, it would actually cancel squeaky clean. But once again, I'm not trying to pretend here that 4 minus x and x minus 4 are exactly the same thing, because they're not. They're not exactly the same thing. But you can still cancel them out. But what would remain is a negative 1. You can cancel this and this, and what's left behind is a negative 1, because if you want the full story, if you were to like factor out a GCF of like negative 1 from this right here, if you were to literally factor it out as like a so-called GCF, what you'd be left with is exactly the same as x minus 4. So that's why. So things like this that are comparable in the same way these two guys are comparable, you can actually cancel those out, but what's going to be left behind is a negative 1. I figured that was like that was relating to this. So 4 minus x and x minus 4 don't cancel clean, but almost. And I just explained how when they cancel, you'll have a negative 1 left behind. And so after all the canceling and stuff like that, what you're left with is this, which I just brought the negative 1 like way out in front. Okay, whatever. And then if you care about this other thing that I'm excusing everybody from, this would lead to like x can't equal negative 2/3, and x couldn't also be allowed to equal positive 2 or positive 5/7 or positive 4. Woo, okay, so look, gang, remember, just when you're simplifying a fraction, just make sure that you already have factors, because you have to factor first. And when you're multiplying fractions together, you also want to be simplifying, so you want to factor and cancel. And then dividing by a fraction is just like you've heard since 5th grade, I don't know. So I think this section 8-4 shouldn't be too crazy, especially since I'm cutting out this side of things, like this brand new sort of concept. And we're just sticking with like how to deal with fractions and factoring and canceling, you know what I mean? So this shouldn't be too bad, okay? But let me know if you have any questions.